I want to turn away from structure of scientific revolutions and now to that essay, Objectivity, Value, Judgment, and Theory Choice, to sort of try to, I think, maybe sort of put a capstone on Kuhn's legacy for the purposes of this lecture. Now, the core thing that he comes out saying at the beginning of this essay is that he is not a relativist, that what he says in Structure of Scientific Revolutions does not commit him to relativism, and anyone who thinks otherwise has misread what it is he said. He doesn't really take ownership. He doesn't say that he expressed himself poorly, but although I think a lot of this, it does have to do with him expressing himself poorly. But either way, that, at a minimum, that's not what he intended. What people were reading was not what the argument he was trying to make. He does admit, like I said earlier, that one paradigm can be chosen over another, but it can't be done on the basis of proof. It cannot be done in a sort of a formulaic or algorithmic fashion where it's rationally undeniable you have to go this way rather than another. So that's just another way of basically saying there is no sort of single scientific method which exists across all paradigms that you can use to decide between paradigms. Nonetheless, he says, that doesn't mean that we can just say, oh, well, I'm going to go with this paradigm. I'm going to decide to be a Copernican rather than a Ptolemaic, I guess it would be. It's not just a matter of sort of throwing up our hands and anything goes and you can just choose whatever you want. He actually thinks that we should defer to the judgment of the scientific community because, quoting Kuhn directly here, what better criteria could there be? If the scientific community ends up resolving around a particular paradigm, the rest of us should do that too. Not thoughtlessly, not mindlessly, but there's a very good reason for us to sort of get behind the scientific community's judgment here. Now, what this sort of implies for some of Kuhn's critics, in particular a guy by the name of Emir Lakatos, Lakatos said that this just means that, according to Kuhnian philosophy of science, science is just mob psychology. As soon as like 80% of the scientific community ends up lining up in a particular way, the rest of us should just all get on board because it's not rational, it's not reasonable, we just got to go with the flow. That was Lakatos's criticism. We'll talk more about Lakatos in the next lecture. And the idea that science is just mob psychology, that theory choice is simply a matter of mob psychology, is something that Kuhn explicitly wanted to reject. He wanted to reject this criticism from Lakatos. Because Kuhn thinks that there are good reasons to choose one theory over another. There are good reasons to go with one paradigm over another, because some theories are in fact better than others, and some paradigms are in fact better than others. The key thing, though, is that better here needs to be understood in a very particular way. It is not in this sort of naive enlightenment picture of in the sense of, oh, well, there's the data favors this theory over that theory. That's the naive picture that Kuhn wants to challenge. To say that there are good reasons, or that there are better reasons to prefer one theory or one paradigm over another requires a lot more subtlety than that. So what makes one theory better than another according to Kuhn? Well, this brings us to Kuhn's famous 5 ways. There are 5 ways of measuring the quality of a theory according to Kuhn. The first idea is sort of fairly straightforward, accuracy. And this is what most people think of sort of when they think about a scientific theory. They say, which is the more accurate theory? And if the predictions of the theory match your observations, obviously that is a benefit for the theory slash the paradigm. That's what you want to be going for. And it's generally considered to be one of the most straightforward scientific values. But it's not the only scientific value. Consistency is another important scientific value. A theory obviously should be consistent with itself, but it should also be consistent with other accepted theories. One of the biggest problems in physics right now is that the best understanding of relativity does not appear to be consistent with the best understanding of quantum mechanics. And that inconsistency strongly suggests that there's a serious problem with either or both of these two theories. Now, both of these theories are incredibly accurate. They make remarkably accurate predictions. But there has to be, it seems, a flaw somewhere with at least one, if not both of them, because they are not consistent with each other. Scope is also important. We want a theory that allows us to make sense of unobservables. We want to make unobserved entities. We want to have a theory not just that accounts for all the data that we have, but a theory that can account for future data that we expect to find. A theory that can only make sense of past data, but provides us with absolutely nothing in terms of what to expect in terms of future data. That can broaden our horizons and allow us to explain things which were previously inexplicable. That's going to be a problem for a theory. A theory needs to have broad scope and not be limited in scope, and the broader the scope, the better. There's also simplicity. This is just sort of straightforward Occam's razor material here. A theory that can order phenomena in a way that was sort of more straightforward, that can show order where there was once confusion, that's going to be a better theory, all other things being equal. And then the fifth and final point is the idea of fruitfulness, or sometimes it's called fecundity. A good theory is one that should provide future scientists with research programs. It should allow them to say, this is an interesting question, I'm going to research this, or I'm going to delegate this to my students and sort of show them how to do it this way. The more fruitfulness that their scientific theory can produce, the more it will be accepted by scientists, because scientists like doing work. A theory that allows them to ask more questions and to perform more experiments is going to be a theory that's going to be attractive to them, because it allows them to investigate things that they were unable to investigate before. If a theory has no fecundity, if it doesn't allow them to provide new research, then scientists aren't going to like it, not because it's inaccurate or inconsistent, but simply because it leaves them with nothing left to do. They're going to gravitate towards a fruitful theory over a non-fruitful one for that reason alone. Now, again, all of these sort of 5 ways should be understood as sort of broad as possible. Now, it's obvious that these are, they might sound good in the abstract, but when you actually look at real-world cases, it's very hard to apply them. I mean, and the first reason why is because all 5 of these values are rather imprecise. I mean, what they mean in one circumstance is going to be different than what they mean in another circumstance, and people might interpret, what it means to be accurate, for example, in different ways. I mean, accuracy tends to be the most important of the 5. Again, I think if you were to had to pick any one of these 5, accuracy is probably the one that most practicing scientists are going to favor. But it can't always distinguish one theory from its competitor. And take Copernicus versus Ptolemy, for example. Copernicus's astronomy was no more accurate than Ptolemy's astronomy. Both of them made more or less the same predictions given based on the instrumentation that was available at the time. So if all you appeal to is accuracy, you're not going to be able to choose Copernicus over Ptolemy. And it wasn't really accuracy itself that ultimately made the decision. And to make matters worse, one theory might be more accurate in one regard, say terrestrial mechanics, but less accurate in another, say celestial mechanics. So which is more important, this regard or that regard? Is it more important to make accurate predictions in terms of your celestial mechanics, or more important to make them in terms of your terrestrial mechanics? There is no sort of straightforward or obvious reason to prefer one over the other. So accuracy is something that can be imprecise, it can be vague, and it can be unclear. A second problem, is what to do when conflict happens. Obviously, if all 5 of these criteria favor one paradigm over another, it's pretty clear where you go. You go with the paradigm that's favored by all 5. But what happens when 2 of these 5 favor one, and then 2 of them favor the other, and then the 5th one's unclear? There's no sort of calculus, there's no sort of formula that you can apply to say that this is how you manage, this is how you marshal the 5 ideas. You're never going to be able to prevent conflict. In fact, the entire reason why you have scientific crises is because some of these values will go one way and some of them will go another. Now, Ptolemy, for example, his theory was actually far more consistent with other scientific theories that existed at the time. Ptolemy had consistency on his side, but Copernicus had simplicity on his. Ptolemy had to do all kinds of strange ad hoc hypotheses to explain away things like retrograde motion and so forth. Copernicus needed none of that. So what's more important, consistency or simplicity? Now, again, it's easy for us to say in retrospect, well, obviously Copernicus was right, so it must be simplicity. But you're cheating if you do that. Imagine yourself a scientist at the time trying to decide between these 2 competing paradigms. It's not at all obvious that you would prefer simplicity over consistency. In fact, you may end up siding with Ptolemy because of consistency rather than Copernicus. Now, you probably would have been judged as wrong, but from the point of view of history. But like Kuhn says, we only know that because we have the benefit of hindsight, because the winners have written the history books. It's also important that we don't rule out the role of purely non-scientific factors, because non-scientific factors will also play a role. It's nice to think of scientists as being perfectly rational entities, but they're not. They're only human, and they have the same kind of human foibles as everyone else. Social atmosphere, social pressure is going to make a difference. If people get ridiculed for their ideas, they're less likely to pursue them, all of the things being equal, than if they get support for their ideas. Politics is going to play a role too. People like to say things like science is apolitical, but that's simply not true, because politics always impacts how human beings live their lives. Personal disposition. If you're the kind of person who likes crazy new ideas, you're more likely to pursue a crazy new theory. Whereas if you're more sort of conservative in your disposition, you like the status quo, you're less likely to pursue radical, altering new paradigms. And of course, economics makes a huge difference. Whether or not your research program gets funding is going to be a huge factor into whether or not you're actually going to pursue that particular route of investigation. If you have 2 options, one that's going to get funding and one that's not, all things being equal, you're going to go with the one that gets funding. These factors all play an influence in how scientists go about their investigations. So, quoting Kuhn directly here, every individual choice between competing theories depends on a mixture of objective and subjective factors, or of shared and individual criteria. Again, this isn't to say that data and evidence and that stuff is irrelevant. It obviously is. He says right there, it depends on a mixture of objective factors, but it's not just the objective factors. That's the important thing, and that's the thing that Kuhn thinks most people have gotten wrong. The subjective factors are just as important. And there is no sort of algorithm, no single scientific method that you can put forward that would allow you to decide between competing theories. Two scientists, each with the exact same data, equally committed to these 5 values, may end up coming to differing conclusions as to what they think is the best one. And in the moment, there's no way of sort of just automatizing it. The only judgment can be made is historically. After a generation goes by, you look back, one of these theories will hopefully have settled on as the correct one, and the other one will be settled on as the incorrect one. But don't make the mistake of thinking, well, that other guy was stupid. That other guy was just an idiot. It wasn't. He had very good reasons for thinking what he was thinking, and he had pretty much the same epistemic commitments as his competitor. It's just these sort of other values ended up tipping the balance against him. Kuhn thinks that his critics can value the role of subjective factors in the context of discovery, or that is to say, the development of scientific theories. But they're of the opinion that when it comes to justifying scientific ideas, scientific is purely objective. So the subjective roles are fine when it comes to generating new ideas, but when it comes to testing them, when it comes to the justification, that should be a purely objective procedure. And again, Kuhn thinks this is kind of naive. Kuhn thinks that they come to this conclusion because of what he calls scientific pedagogy, textbook science. When you pick up a textbook in physics or chemistry, you will only see these successful experiments. You will almost never look or hear anything about these experiments that ended up failing. The paradigms that have been thrown out are only presented as a contrast by way of saying, oh, here's this sort of foolish idea, here's this silly idea, here's an idea that people used to believe, now we know it's false. And it presents this idea that the paradigm cases clearly favor one view over another, and that is authoritative, that is objective proof. But that's not how it works in actual history. You know, the problem with pedagogy is that these cases are selected by the people who write the textbook specifically to indoctrinate students into the scientific community. You want to teach them the dominant paradigm. If you have to teach them the ideas that have been rejected as well as the ideas that have been accepted and sort of show them the full history, well, that takes an awful long time. That gets very confusing. There's only so many hours in the day for a science class anyway. So it sort of makes sense that they're going to focus on the material that's crucial for the dominant paradigm. And that's where this Enlightenment picture of continual progress comes. So they will drastically underdescribe the considerations that goes into deciding between the two competing theories at the time. The reason why these paradigm cases are viewed as paradigm cases is because they illustrate the purpose, the principle, so well. They ignore, or at least pay very little attention to, the more ambiguous cases where it's not quite so clear as to whether or not this experiment favors the one paradigm versus the other. Nothing is said, or very little at least is said, about the considerable merits of Ptolemaic astronomy. I think I've mentioned it before in this lecture series. You can use Ptolemaic astronomy to navigate from Portugal to New York City and land within 50 miles of your destination. You don't need a compass. All you need is some clear nights and a fairly decent grasp of Ptolemy's star charts. That's an incredibly powerful theory. You could not do that with Copernicus. That's something that Copernicus does not empower you to do. So when you see it in that context, it's actually far from clear that you should prefer, at the time, Copernicus over Ptolemy. And there's also very little talk about these sort of less than decisive considerations that went into adopting the paradigm at the time. Consider, for example, Johannes Kepler, who was a big supporter of Copernicus. He was played a big role in laying the foundations for Galileo to come along. And Copernicus was saying, no, Kepler, like Copernicus, said that the sun is at the center of the solar system. What's not mentioned is that Kepler himself was literally a sun worshipper. I don't mean that he enjoyed the sun, that he liked to get a suntan. I mean he had a religion that treated the sun as if it were a deity. It is a very unorthodox vision, but it's true. Do you think that maybe, just maybe, that might have influenced his thinking when it came to accepting the Copernican paradigm over the Ptolemaic paradigm? that's not something that we mention in there because we don't like to think of our scientists as being dictated by personal values in this way. But that is, in fact, how scientists work, because scientists, once more, are only human. They cannot be dictated exclusively by scientific values. They are dictated by non-scientific factors as well. Back to the idea now that Kuhn stresses, which strikes many people as strange, the idea that it's good that there is no scientific method. And by scientific method here, I mean you can just sort of an algorithm that will always allow us to sort of plug and chug and decide which theory to go with. Anytime there's a crisis, anytime there's a conflict, we just put the data into the machine, and the machine will spit out the answer. We should prefer this paradigm over that paradigm. In that sense, there is no scientific method. There is no scientific algorithm. And it is a good thing, Kuhn says, because if there were such an algorithm, then there would be no room for dissent. There would be no room for someone coming along and saying, hey, you know what, I don't accept the dominant paradigm. But science needs that room for dissent. It needs people to think, I'm going to use the terrible, horrible phrase I realize. It needs to allow people and empower people to think outside the box. That kind of lateral thinking is what allows there to be scientific revolutions in the first place. If we did not have that kind of freedom in science, then you never would have had Isaac Newton overturn the Aristotelian or the Cartesian view of gravity. You never would have had a Charles Darwin that could have had the intellectual freedom to challenge the visions of people like Lamarck that came before him. That sort of thinking is crucial for scientific progress. It's crucial to be able to have people that don't just follow algorithms, that instead can use creativity, that allow them to imbue a vision of the world which differs from the dominant one. If there were an algorithm, then all scientists would have to follow the same conclusions. The algorithm would dictate that this is the right thing to do, and they would have to go that way. So rather than a calculation, rather than an algorithm, Kuhn says that we should take these 5 criteria as values, scientific epistemic values. And these values influence rather than determine theory choice. You can't simply sort of make a calculation by saying accuracy matters this much, consistency matters this much. Rather, you need to take a look at all the evidence that you can. You need to look at the competing paradigms and how they account for that evidence, and then you need to bring these 5 values to bear, and using your best judgment, which cannot be automated, determine what way to go you think is the best. Now, some of your fellow scientists will agree with you, some will disagree, and that's when the debate has to happen. And some people will shift from one paradigm to the other, and one way or the other, the dispute will be resolved. But the idea that this is done entirely on evidence is mistaken. This is determined largely by values, by these scientific epistemic values. Kuhn stresses here that you should not, once more, fall back into the idea that theory choice is just relative. It's subjective. It's entirely a matter of personal opinion. If I like this theory, then I can go with that theory, and if you don't like it, then you can go with that one. It's like choosing an ice cream flavor. That's not what Kuhn is saying. And to explain why does he thinks people think that's what he is saying, and to explain what he actually means, he wants to bring up an ambiguity which is often unnoticed in the subjective-objective distinction. Sometimes the word subjective is used in contrast with the word objective. And in this sense, again, the implication seems to be that what is objective is something that all fair-minded people have to agree upon, and what is subjective is something that's allowed to be open to the individual to decide. Sometimes, though, subjective is sort of used in contrast with the notion of being judgmental. And Kuhn says when you conflate these two different ideas, subjective versus objective versus subjective versus judgmental, things get very, very confusing. So he uses a movie analogy, and I'm going to use a very specific film here because I had this experience once. It's the Will Smith film Wild Wild West. So let's say that me and my friend go see the film Wild Wild West, and we come out of the theater and we do what friends always do, say, "What'd you think?" And I say, "Oh, I loved it." And she says, "Oh my God, I hated it." Now, there's a very clear sense in which this is purely subjective, in which this is sort of purely a matter of taste. If I liked the film and she did not like the film, there's no real rational disagreement going on there. It's not like she could present an argument that would make me say, "Oh my gosh, you're right, I did not enjoy that film after all." Or I could provide an argument with her. It's not like I can say, "No, you didn't hate that film, you actually loved that film." There's no real sort of debating that. If you loved it, you loved it. If you hated it, you hated it. You can't argue your way out of that. And in that sense, it's purely subjective. But there's another sense in which it's not quite so clear, because you can in fact debate the judgment that the film was a good film or a bad film, because we share common standards as to what makes a good movie. If my friend and I are both movie buffs, if we go to a lot of movies together, we talk about movies together, we are going to share common standards for what makes a movie a good movie. For example, it has to have good dialogue. It has to have a well-structured plot. It has to, have this element versus that element. And we can debate whether or not the film in question in fact had those elements. If the dialogue is full of corny one-liners and hackneyed cliches that have been repeated in 1,000 movies before, it's very hard to argue that the dialogue is good dialogue. But we might argue that, well, maybe dialogue in this film wasn't the important part. Maybe the dialogue is less important. So we can debate whether or not the standards of what counts as a good movie apply to this movie. In that sense, we can very much have a rational disagreement about whether or not our shared standards evaluate this film as a good film or a bad film. Now, that doesn't mean that it's objectively a good film or a bad film. It just means that if we can agree upon basic standards of what makes a good film and what makes a bad film, then we should be able to apply those standards consistently in the case of the movie. For the record, when I saw Wild Wild West, I did walk out of the theater thinking it was a good movie. A friend of mine, it was actually a male friend of mine, said it was a bad movie, and we ended up debating for some time about it. And as I thought about it, again, he talked me out of it. I reflected on the film, and I realized that my friend was right. That actually was a shitty movie. It wasn't a very good movie, even though I enjoyed it upon first watching. And the reason why is because I kind of dropped my standards. I wasn't really thinking about my standards for good taste at the time. Now, whether or not that's something we should do or we shouldn't do is a question for aesthetics, whether or not it's better to enjoy a film, even if that means dropping your standards, or whether or not it's better to hold your standards consistent is another issue. It goes beyond the scope of this lecture, but I hope you get the point. Even though taste is to a certain extent purely subjective, that doesn't mean that we cannot have rational conversations about whether or not something meets our shared standards. I hope you can see how we apply this in the context of science. Theory choice is more like the latter point, Kuhn says. It's not just a matter of taste. It's not like you can go, well, I'm a Copernican because I prefer Copernicus's theory. It tastes better to me. You're a Ptolemaic just because you prefer that taste. That's not at all how Kuhn thinks science actually works, because science is not beyond the scope of rational discussion. It's not an objective fact in the way that it's just sort of out there to be determined, but it is a judgment call. And thankfully, nearly all scientists share at least roughly the same criteria for what counts as good scientific judgment. Again, go back to his 5 values. If one paradigm is more accurate, more consistent, has better fecundity, and so forth and so on, pretty much all scientists are going to favor that paradigm over the other paradigm, which lacks all 5 of those values. It only gets tricky in this fairly rare number of cases where you have something like a 50-50 split, or maybe 2 of the values favor one paradigm, but it's the 2 most important ones. That's the only part where sort of it becomes a problem, where the exercise in judgment really becomes a difficult issue. Now, a term which is sometimes used here to differentiate it from the sort of objective-subjective distinction is the term inter-subjectivity. The idea behind inter-subjectivity is the idea that it's not an objective fact that these things are preferable, but it appeals to the idea that both parties, or all parties in a debate, share a certain underlying set of criteria, not an objective criteria, but because of that shared criteria, they can challenge and criticize each other for failing to live up to their own self-professed commitments to those criteria. So intersubjectivity is sometimes put as a third path between objectivity and subjectivity. And I think if you wanted to reduce Kuhn's ideas to sort of a bumper sticker, what Kuhn is saying here is that theory choice is not objective, but neither is it purely subjective. It is rather intersubjective in nature. But what about incommensurability? What about the whole foreign language analogy? Wasn't he saying before that you can't translate from one theory into another? Doesn't this sort of shoot everything he's saying here in the foot? And Kuhn sort of wants to hold on to the foreign language analogy, but he also wants to water it down some. Proponents of different theories are indeed like speakers of different languages, but Kuhn says we can translate between 2 languages. Now, there's no sort of objective language. There's no sort of criteria which you can say that this language is objectively better than another. Some languages will be better at some tasks. German, for example, tends to be very good at giving orders, at giving commands, at giving imperatives, whereas Italian is sort of much more of a straightforward poetics language. It sounds more beautiful. They're going to have certain merits and certain demerits, but there's no sort of objective criteria which you can say this is the best language or this is the worst language. But that doesn't mean that they can't be compared. There are sort of, if you can sort of agree upon what you want your language to do, if you can start with that intersubjective agreement as to what it is we're trying to have language accomplish here, then we might be able to say that this language is a superior language over that language because there are concrete technical results which you can achieve with one language that you cannot achieve with another. Again, and by analogy, concrete technical results that you can achieve within one theory that you cannot achieve with another. Now, this doesn't sort of resolve all of Kuhn's problems. Again, there's still a whole lot that can be debated, but I do think this seems like a start. It is nice sort of to see Kuhn dial back on some of his radical claims, but while hopefully holding on to the heart of what makes it interesting. But whether or not we're ultimately going to accept Kuhn's thinking is something that sort of we have to decide for ourselves, so to speak. And so in the next lecture, we'll look at some of Kuhn's big critics, in particular people like Emir Lakatos, who I mentioned earlier in this lecture, and see how it is that they try to sort of take the heart of what Kuhn has to say and improve upon it in various ways.